Hello everyone, and welcome back to class. I see we're in week 2 of the course. And this week, we are going to cover the scientific method. Now, what is the scientific method? Well, the scientific method is a way for scientists to systematically study a phenomena that they encounter. The scientific method is a series of steps. And this series of steps was originally devised by the classical Greeks as part of their developing philosophy as a civilization, and it carries through into scientific thought and a process that we embrace as scientists today. The scientific method is a set of generalized steps. What that means is that we will take a look at these different steps and we will use them as a way to inform our decisions and how we view the world around us. The scientific method starts off with an observation. How do we view the world around us? You see, our bodies, as part of homeostasis, are encountering a variety of different stimuli, both internally and externally. And every interaction we have helps us better understand if we're truly seeing a phenomena that's occurring in the world around us. You know, we can use our 5 senses. Some good senses that are commonly used would be like sight, hearing, and smell, even taste. But as we move through and observe the phenomena, we need to be able to find a way to ask questions about it, to help inform our thinking. We call that a hypothesis or educated guess. Then we have to be able to test if our guesswork is correct by using experimental design. Design an experiment and collect data. That is the main goal of the application side of our labs this semester. Then we analyze the results from those experiments and see if they inform if our observation is correct. Think of the scientific method as a way of checks and balances, but at the end of the day, it's a guide for us to better understand the world around us. As we use the final step, communication, to be able to share ideas as part of an intellectual currency, where I share ideas with you about biology, and you can share ideas with me about how you understand and conceptualize the model, which is going to be the completed experiment. Taking an abstract idea based upon observation and turn it into a concrete model. So earlier I talked about experimental design. Experimental design is a way for us to collect data. So that way we can determine if our hypothesis is correct or very well supported, or maybe has a little bit of error running behind it. Maybe a bias, or maybe it's grounded in pseudoscience, which is not really great science. And so we need to be able to support our hypothesis as strongly as possible using good, accurate, but yet precise experimental data. When you build an experiment, you need to be able to have variables. You have an independent variable, which is one that you change, and a dependent variable, a variable that will change in response to that independent variable. And then you also have to have a control. That control is a standard of comparison. And in fact, I actually have an experimental design right here. So this is actually one of my favorite experimental designs that I typically use more in, say, like a chemistry class when we study reactions. But seeing that in our second theme of the course, we study reactions a little bit on the biochemical level. So I'm going to actually just show you a little bit about these reactions. So I have 2 bottles of soda. This will be my independent, they're going to both be independent variables. I have a berry soda and I have Diet Coke. The Diet Coke is going to also represent my control, a standard of comparison. Because what I'm going to be doing is recreating my again, my favorite experiment to show chemical reactions by introducing Mentos. See? And we're going to be introducing them to the soda because my hypothesis would be that I want to better understand how chemical bonding and reactions may occur. When you introduce the Mentos to the carbonated soda beverages, it starts a chain reaction that will eventually eliminate all the carbon dioxide within the soda, basically make it flat, but it will push out all the oxygen, causing the soda to erupt. And you may have seen this on various social media platforms like TikTok and Snapchat and Facebook. It's quite the rage. And the data that we're going to be collecting and graphing will just be time. See how long the reaction lasts in relation, and we can write it down. That's the one thing about science, is that there is a difference between messing around in a lab and writing it down. I learned that on the show Mythbusters. So let's actually run our experiment. I'm going to open up the sodas. And my goal is I want to see if the berry soda has the same reaction as the Diet Coke. So 3, 2, 1, drop the Mentos. You see on how it's fizzing? So that tells us that our control worked. It followed the methods of the experiment, and we got the result that we were looking for. Now, let's take the Mentos and drop it into the berry soda and see what that reaction may be. Oh, and now we actually have the same reaction, which will be the fizzing soda, and the reaction visually looks very similar to what we saw in the Diet Coke. So that tells me that no matter what kind of soda we use, the reaction with the Mentos and the carbonated drink will still occur. And that's the beauty of the scientific method, is it's a way for us to take a phenomena, conceptualize it, and then test it in a physical model. Now, in lab this week, we are also going to be conducting a little bit of a thought experiment. So, one of the main goals in science is also what they call peer review, where other scientists go out and evaluate other scientific works. And so what we can do that by just taking a look at what they call the published record. Academic papers that get published in a lot of the science communication websites that you may actually read in your spare time. But there's a lot of science that goes behind that and that drives our scientific understanding and promotes more intellectual exchange. So the year is about the 1600s. And during the 1600s, we have in Americana history, the Salem witch trials. You may have heard this in middle school, high school, even elementary school. But the Salem witch trials actually is a really good way to think about the scientific method because something scientific was actually going on in there. And our goal as scientists is be able to separate our thinking away from folklore, away from pseudoscience into more concrete science. And there has been a lot of research that has been done about how scientists better understand the Salem witch trials and them being able to go out and analyze experiential phenomena, historical records, medical records, and be able to write their own hypothesis and analyze very well collected data despite the time, to be able to confirm or deny, to support or unsupport what may have occurred in Salem in the 1600s. And that's what we're going to be doing in lab, is just looking at the current research and then critiquing that research, see where it applies. Look at charts and data, graphs, if you will, and determine, are we seeing good trends or not to support our hypotheses, and did the scientific method come into play in Salem in the 1600s? So if you have any questions about this week's content, please reach out. You can stop by my office in room 208. You can send me an email, or we can set up a video chat. Now, if you'll excuse me, I've got a lot of soda to clean up from this awesome chemical reaction. All right, thank you, and have an excellent day on planet Earth.